Chapter 2. In the chapter The Magic of Chemical Reactions, let us study about the chemical equations and types of chemical reactions. Dear students, in day-to-day life, you come across some temporary, physical, and some permanent or chemical changes practically every day. Classify the changes given below into physical and chemical changes. Situation, physical change, chemical change. Ice changes to water is a physical change. Milk is set to curd is a chemical change. Ripening of fruit is a chemical change. Steam condensed is a physical change. Your respiration is a physical change. Sometimes substances, that is reactants, react to form a new substance, that is product, which in turn is able to form original substance under certain conditions. This is a temporary change. For example, water freezes to ice. On heating, it forms water again. When reactants are permanently converted into a new product, chemical change takes place. A ripe mango cannot be made raw again. When a chemical change occurs, a chemical reaction takes place. Let us perform some activities. Activity 1. Take a tablespoonful of copper powder in a china dish. Heat it strongly. What changes do you observe? A black substance is formed, which is copper oxide. The reaction is given as 2Cu plus O2 gives 2CuO. Let us fill this table. Change in color. Reddish brown to black. Evolution of gas. No gas evolved. Change in temperature. No change in temperature. Change in state. No change in state. Activity 2. Take a small piece of aluminium wire and burn it. Record your observations. It cannot burn easily as aluminium reacts with air. A thin layer is formed on wire. This is aluminium oxide. Further reaction is not possible till oxide layer is removed. Let us note down the observation in this table. Change in color. It turns gray. Evolution of gas. No gas evolved. Change in temperature. No change in temperature. Change in state. No change in state. Remove a tungsten wire from a fused bulb. Try to ignite it. What do you observe? It does not ignite. Activity 3. Take barium sulfate solution in a test tube. Take potassium chromate solution in another test tube. Add potassium chromate slowly to barium sulfate solution. A yellow precipitate of barium chromate is formed along with potassium sulfate solution. Barium sulfate plus potassium chromate gives barium chromate plus potassium sulfate. Let us fill this table. Change in color. Color changes from white to yellow. Evolution of gas. No gas evolved. Change in temperature. No change in temperature. Change in state, from liquid to solid. Activity 4. Take some dilute sulfuric acid in a test tube. Take some iron sulfide solution in another test tube. Add a small quantity of dilute sulfuric acid to iron sulfide very slowly under supervision of your teacher. Touch the test tube. Also experience the odor. What do you observe? There is a change in odor, temperature and color. You get the smell of rotten eggs from H2S. Let us note down the observation in this table. Change in color from blackish gray to green. Evolution of gas. H2S gas is evolved. Change in temperature. Test tube gets hot. Change in state from liquid to solid and gas. Activity 5. Heat camphor in a porcelain dish. Keep a funnel plugged with cotton over the dish before you heat. What do you observe when camphor burns? We can see vapors rising. What happens when the apparatus is cooled? The vapors cool and stick to the sides of the funnel. Let us note down the observation in this table. Change in color from white to black soot. Evolution of gas, vapors of camphor arise. Change in temperature, no change in temperature. Change in state, from solid to gas. A chemical change accompanied by chemical reaction not only changes nature and appearance of the reactants, but also changes the identity of the reactants by bringing about change in color, temperature, state of the substance, and sometimes evolution of gas. Example, salt obtained from seawater. Every action is an activity. Each activity with chemical change results in a chemical reaction, which is represented by a chemical equation. Let us see what is meant by chemical equation. You all must have heard about National Council of Education Research and Training, National Environmental and Engineering Research Institute, Bharat Sanchar Nigam Limited. Their abbreviated forms, that is NCERT, NEERI, BSNL, are convenient and easy to remember, isn't it? Let us take a reaction. Say, when copper powder is heated, black copper oxide is formed. We can represent it as copper plus oxygen gives copper oxide. Representing chemical reactions in words is called a word equation. Let us see how to write a chemical equation. During the reaction, the substances that undergo change are called reactants. In above equation, copper and oxygen are the reactants, which react together to form a totally new black-colored substance, copper oxide, which is a product of the reaction. The reactants are always represented on left-hand side, whereas the products are on the right-hand side of the equation. An arrow in between them always points towards the product and tail towards the reactants. The arrow also represents the direction of the reaction. If there are two or more reactants or products formed, they are written with a plus sign in between them. For example, when you mix vegetable oil with nickel powder as a catalyst and heat it with hydrogen gas, fats are obtained on cooling. When oils get converted to fats, the reaction is to be carried out in presence of nickel, which acts as a catalyst at high temperature. Certain reactions have to be carried out under specific conditions of temperature, pressure, and catalyst. These conditions are mentioned on the arrow pointing from reactants to product. The physical states of the reactants and products are to be mentioned in the chemical equation when necessary to make it more informative. The gaseous, liquid, and solid states are symbolized as G, L, and S respectively. Edible oil, a liquid, plus hydrogen gas on heating gives fats a solid. If you observe that the reactants or products are present as solution in excess of water, what symbol do you use to represent it? We use the symbol AQ for aqueous. Let us consider equation Cu plus O2 gives CuO. Count the number of atoms of each element on both reactant and product side. Is the number of atoms of each element same on both sides? If not balanced, it is due to the unequal mass of the atoms on both sides. In such a situation, the equation can only be the skeletal chemical equation for burning of copper to form copper oxide. Let us see how balancing of the chemical equation is done. Let us take the word equation iron sulfide plus sulfuric acid gives ferrous sulfate plus hydrogen sulfide. Its chemical equation can be represented as FeS plus H2SO4 gives FeSO4 plus H2S. The table shows that there is one iron atom each on left and right sides, two sulfur atoms on both sides, two hydrogen atoms on both sides, and four oxygen atoms on both sides of the equation. When number of atoms are the same on the LHS or left-hand side and RHS or right-hand side of the chemical equation, then the equation is said to be a balanced equation. Let us now see the steps involved in balancing any equation. To get a balanced equation, there are a number of steps. Try to balance the following equation. SO2 plus H2S gives S plus H2O. Step 1. Rewrite the given equation as it is. SO2 plus H2S gives S plus H2O. Step 2. Compare number of atoms of each element in the given equation on both sides of the equation. We can see there are two sulfur atoms on left side and one sulfur atom on right side, two hydrogen atoms on both sides, two oxygen atoms on left and one atom on right side. Step 3. Choose the reactant or product having maximum number of atoms. In the given equation, select SO2 and the element oxygen in it. You have already noted that there are two oxygen atoms on LHS and only one on RHS. Equalize the number of oxygen atoms to balance there. While equalizing the number, remember that you cannot change the formulae. That is, to balance two oxygen atoms, do not make H2O as H2O2, but change the coefficient of the complete molecule of the deficient side, whether LHS or RHS. In your given equation, the deficient side is right-hand side H2O molecule. Hence, put proper coefficient 2 for H2O molecule to balance oxygen atom, that is 2H2O. Your partly balanced equation can now be expressed as SO2 plus H2S gives S plus 2H2O. Step 4. S and H atoms are not yet balanced. You may select any one of the two. Select hydrogen atoms for balancing. Let us equalize the number of hydrogen atoms. There are two hydrogen atoms in reactants and 4 in products. We multiply 2 in H2S by 2 to balance. Make the number of H2S molecules on left side as 2H2S to get balanced hydrogen atoms. Equation would now be SO2 plus 2H2S gives S plus 2H2O. Step 5. You now need to select S, the only element left to be balanced. Atoms of S in reactant is 3, that is 1 in SO2 and 2 in H2S. In product, there is only 1 in S. We multiply 1 by 3 in right side. To equalize number of sulfur atoms, you can make 3 atoms of sulfur on right side. SO2 plus 2H2S gives 3S plus 2H2O. Step 6. Count the number of atoms of each element in equation on left side and right side. There are 3 sulfur atoms, 4 hydrogen atoms, 2 oxygen atoms on both sides. You will notice the number of atoms are same. Hence, equation is a balanced chemical equation. Please indicate the physical states of reactant and product when necessary as mentioned previously. SO2 gas plus H2S gas gives 2S solid plus 2H2O liquid. The conditions of the reaction, if any, are to be indicated above and below the arrow between left side and right side. For example, in the given equation, 323 stands for temperature. Reaction takes place with alcoholic concentrated hydrochloric acid, which is shown above the arrow. Let us try to answer some questions. 1. Name the reactants and products in equation. Answer. The reactants are sugar and water, and the product is 2 molecules of glucose. 2. What is the name of process in equation? Answer. The name of process in equation is polymerization. 3. Balance the given equation. Cu plus O2 gives CuO. Answer. Count atoms of Cu and O on left and right sides of equation. Balance oxygen atoms, right side is deficient, so we multiply CuO by 2. Now Cu on left is deficient. Multiply by 2. Equation is balanced. 4. Write the balanced equation for the following reaction. Barium chloride plus sulfuric acid gives barium sulfate plus hydrogen chloride. Answer. Balanced equation is as given. BaCl2 plus H2SO4 gives BaSO4 plus 2HCl. 5. Write the physical states of the reactants and products in the reactions. 1. AgNO3 plus NaCl gives AgCl plus NaNO3. Answer. On writing the physical states of the reactants and products in the reactions, we get AgNO3 gas plus NaCl aqueous gives AgCl solid plus NaNO3 aqueous. 2. Zn plus 2HCl gives ZnCl2 plus H2. Answer. On writing the physical states of the reactants and products in the reactions, we get Zn solid plus 2HCl aqueous gives ZnCl2 aqueous plus H2 gas. Now we will see different types of chemical reactions. Chemical reactions involving breaking and making of the bonds between the atoms to produce new substances. You must be aware that various chemical reactions occur in and around you. Let us take a look at combination reaction. Let us look at the one interesting phenomenon. Rehana and Reshma were having fun with colors in their drawing class. Rehana mixed few drops of red color with white color and got pink color. Reshma mixed yellow with red color to get orange shade. They also prepared violet by mixing red and blue and grey by mixing black and white colors. When you mix Vibgyor colors, what color do you get? We get a band of colors like the rainbow. When two or more substances combine, be it mixture or compounds, to form a single product, then the reaction is known as combination reaction. Let us look at the examples of combination reaction. 1. In the laboratory, you have performed an experiment for the formation of iron sulfide by mixing iron and sulfur. Fe solid plus S solid gives FeS solid. 2. Increase in formation of carbon dioxide in environment leads to acid rains when it mixes with water vapor. H2O gas plus CO2 gas gives H2CO3 liquid. 3. You must have observed at new construction sites that wet cement with sand and gravel sets into concrete, which imparts strength to the building. The chemical equation for this is written as 3CaO Al2O3 solid plus 6H2O liquid gives 3CaO Al2O3 6H2O solid plus heat. Students, do you know that plaster of Paris, when mixed with water, sets quickly into hard mass known as gypsum, which is the raw material in manufacturing cement, 2CaSO4 H2O plus 3H2O gives 2CaSO4 2H2O plus heat. Plaster of Paris is used in surgical bandages, casting and molding in dentistry, in making statues, decoration of roofs, crayons manufacturing, etc. For people involved in construction of buildings and interiors, plaster of Paris is often referred to as POP. During combination of two or more reactants, the reactants may require or release, or in other words, liberate heat with formation of products. Let us perform one activity. Take a small quantity of detergent powder or washing soda in your hand and add a little water to it. What do you feel? Your palm feels hot. Is there any change in temperature when water is added to the detergent? Yes, temperature increases. Let us look at one more activity. Take 100 milliliter of distilled water in 2 polythene bottles. This prevents heat loss. Note temperature of water in both bottles. Add about 5 gram of potassium nitrate to one bottle. Stir well. Note temperature of the solution. Add 5 gram of sodium hydroxide to the other bottle. Note the solution temperature. What do you observe in both the cases? Temperature of solution falls in first case. Temperature of solution increases in second case. What inferences can you draw? First is endothermic reaction and second is exothermic reaction. In the case of KNO3, there is absorption of heat during the reaction. Hence, the temperature of the solution falls. Reactions accompanied by absorption of heat are called endothermic reactions. In these reactions, the reactants require heat or absorb heat to form products. When NaOH dissolves in water, there is evolution of heat leading to a rise in temperature. Reactions where heat is evolved are called exothermic reactions. Students, we know that carbohydrates such as rice, potato, sago, etc. are major sources of energy in our diet. During digestion, these carbohydrates are broken down into glucose. Glucose combines with oxygen in our body and provides energy. C6H12O6 aqueous plus 6O2 gas gives 6CO2 gas plus 6H2O liquid plus energy. Is this reaction exothermic or endothermic? This reaction is exothermic. Now let us move to the decomposition reaction. Before that, look at this situation. Mary was helping her mother to make brown sugar for pudding. After some time, she obtained a black mass instead of brown with burning smell. What do you think happened? Sugar on heating formed carbon and water. In the above activity, a single reactant, sugar, has broken down to give a simple product C and H2O. C12H22O11 solid, when heated, gives 12C solid plus 11H2O gas. Such reactions are decomposition reactions. During industrial manufacturing of cement at a temperature above 1000 degrees Celsius or 1273, calcium carbonate decomposes as follows. CaCO3 solid gives CaO solid plus CO2 gas. These reactions are the decomposition reactions carried out by heating. These are also known as thermal decomposition reactions. See this activity. Take a spatula full of silver bromide on a watch glass. Note its color is pale yellow. Place the watch glass in sunlight. Observe the color after some time. color turns to gray. 2 AgBr solid in presence of sunlight gives 2 Ag solid plus Br2 gas. Similar reaction is given by silver chloride. 2 AgCl solid gives in presence of sunlight gives 2 Ag solid plus Cl2 gas. These reactions are used in black and white photography during the process of developing. You must have realized that decomposition reactions require heat and light energy. Some decomposition reactions are brought about by acids. CaS solid plus 2HCl liquid gives CaCl2 solid plus H2S gas. Let us see how decomposition is carried out by electricity. Will it be possible for you to decompose water by heat or light energy? If you pass current from a 6-volt battery, is decomposition of water possible? When current is passed through acidified water, it decomposes to give hydrogen gas and oxygen gas. We come across various decomposition reactions around you in nature. The organic wastes are decomposed to manure and biogas, which is used as fuel. Let us try to answer some questions based on what we have learnt. 1. Paste of substance A is used to decorate the roof of your home. 1. Name the substance A and write its formula. Answer. Substance A is a plaster of Paris. Its formula is 2CaSO4 H2O. 2. Write the reaction of substance A with H2O. State the name of the product B. Answer. The reaction of substance A with H2O is as given. 2CaSO4 H2O plus 3H2O gives 2CaSO4 2H2O plus heat. Name of the product B is gypsum. 3. Where and how is B useful? Answer. Gypsum is used as a raw material in cement industries. 2. State whether the following reactions are endothermic or exothermic. 1. 3CaO Al2O3 solid plus 6H2O liquid gives 3CaO Al2O3 6H2O solid plus heat. It is an exothermic reaction. 2. 2CaSO4 H2O plus 3H2O gives 2CaSO4 2H2O plus heat. It is an exothermic reaction. 3. KNO3 solid plus H2O liquid plus heat gives KNO3 aqueous. It is an endothermic reaction. 4. NaOH solid plus H2O liquid gives NaOH aqueous plus heat. It is an exothermic reaction. Let us take a look at the next type of reaction, that is, displacement reaction. Let us take a look at the activity. Take completely used 2 cells out of a wall clock, transistor, tape recorder, etc. Remove the material from inside. You will get a can that is made up of zinc. Press and make it flat. Cut into 2 strips. Take CuSO4 solution in 2 beakers A and B. Dip this zinc strip in copper sulfate solution A. Take copper sulfate solution in another beaker B for comparison. Keep another plain zinc strip aside also for comparison. Remove the zinc strip after about 5 minutes. Compare intensity of blue color of copper sulfate CuSO4 in beaker A and beaker B. Blue color fades in beaker A and becomes colorless. Compare the color of the zinc strips. A red-brown copper metal is deposited on zinc strip. You must have often observed during the game of football or hockey that one of the players is asked to come out of the field for some reason and some other player takes his position to complete the team. Similarly, exchange of elements to complete reaction. In the reaction shown, zinc replaces copper to form zinc sulfate. In activity, zinc, which is more reactive than copper, has removed copper from copper sulfate. CuSO4 aqueous plus Zn solid gives ZnSO4 aqueous plus Cu solid. When a more reactive element removes another element having less reactivity from its compound, these reactions are termed as displacement reactions. It is also observed that iron and lead can also displace copper from its compounds. Complete the reaction and name the products. CuSO4 aqueous plus Fe solid gives FeSO4 plus Cu. Now let us take a look at double displacement reactions. AB plus CD is equal to AC plus BD. Let us perform this activity. Take 5 milliliter of copper chloride solution in test tube. Add 5 milliliter of potassium iodide to it. Note your observation. A brown precipitate is formed. This is cupric iodide. A brown substance insoluble in water is formed. This insoluble substance is known as precipitate. CuCl2 plus 2Ki gives Cu(I2) precipitate plus 2KCl. The chemical reactions in which precipitates are formed are precipitation reactions. Another example is AgNO3 plus NaCl gives AgCl precipitate plus NaNO3. White precipitate of AgCl is formed by exchange of ions Ag plus and Cl minus between the reactants. Let us see one more example. BaS plus ZnSO4 gives BaSO4 plus ZnS. BaSO4 is a precipitate. Precipitate of BaSO4 is formed by exchange of ions Ba plus and SO4 minus between the reactants. The reactions where a precipitate is formed by exchange of ions between the reactants are examples of double displacement reactions. Recall this activity. We have added potassium chromate K2CrO4 to barium sulfate BaSO4 solution. So, 1. What was the color of precipitate formed? Answer. The color of precipitate barium chromate formed was yellow precipitate. 2. Name the precipitate. Answer. The name of the precipitate is barium chromate. 3. Write the balanced equation for the reaction. Balanced equation for the reaction is as given. Barium sulfate aqueous plus potassium chromate aqueous gives barium chromate solid plus potassium sulfate aqueous. 4. Is it a displacement or double displacement reaction? Answer. It is a double displacement reaction. Students, the reactions like combination reaction, decomposition reaction, displacement reaction and double displacement reaction takes place with different speeds. The speed or rate at which a reaction takes place depends on various factors like the particle size of the reactants, concentration of the reactant, nature of the reagent, conditions of the reaction, etc. Let us now move to oxidation and reduction. Children, during festivals all of you have fun while bursting crackers. When crackers burn, you will find an ash residue after they are burnt. What reaction has taken place? Chemical in crackers oxidize and give out light and heat. Let us see two reactions to understand oxidation. When aluminium burns in presence of oxygen, oxide of aluminium, known as alumina, is formed. 4Al solid plus 3O2 gas gives 2Al2O3. Consider reaction of metallic sodium with alcohol. 2C2H5OH plus 2Na gives 2C2H5ONa plus H2 gas. The chemical reaction in which reactants gain oxygen to form corresponding oxide is known as an oxidation reaction. Similarly, the chemical reaction in which reactants lose hydrogen to form product is also called oxidation. Let us see what is meant by reduction. See this reaction. C solid plus H2 gas gives CH4 gas. Chemical reactions in which reactants gain hydrogen are reduction reactions. Similarly, the reaction in which reactants lose oxygen atom to form product is also reduction. O3, that is ozone, in presence of light and heat gives nascent oxygen. In this reaction, oxygen is freshly liberated. This oxygen is often called freshly born or nascent oxygen. In a chemical equation, nascent oxygen is always denoted by showing symbol of oxygen in square brackets. When edible oil is converted to fats, what reaction is it? Express this reaction in words. This reaction is reduction. Edible oil plus hydrogen on heating gives fats. Recall this reaction. 2Cu solid plus O2 gas gives 2CuO solid. It is an oxidation reaction. Why? Because oxygen is added. When hydrogen gas is passed over black copper oxide, a pinkish-brown coating of copper is obtained. CuO solid plus H2 gas gives Cu solid plus H2O. It is a reduction reaction. Why? Because hydrogen is added. During this reaction, CuO loses oxygen atom. Hence, it is reduced. At the time, hydrogen is gaining oxygen. Hence, it is oxidized. When oxidation and reduction takes place simultaneously in a given chemical equation, it is known as redox reaction. Let us look at some more examples of redox reactions. See this reaction. In this reaction, BaSO4 loses O2 and is reduced to BaS. 4C gains O2 and is oxidized to 4CO. In the reaction shown, 2H2S is oxidized to 2H2O by adding O2. SO2 is reduced to 3S by removal of O2. Oxidation in and around you. Have you ever peeped into the storeroom of your home? If you have, you must have seen some old and out-of-use articles made of iron. They are usually covered with a reddish layer. Do you know what the red layer is called? Red layer is called rust. When copper articles are exposed to light and moisture, do they undergo corrosion? Yes. What about silver ornaments? Yes, they do. What, according to you, is the reason for aluminium utensils retaining their original shine when green leafy vegetables are boiled in them? Aluminium reacts with air to form aluminium oxide. This makes vessels dull. When green leafy vegetables are boiled, it removes the oxide and reduces to aluminium, which shines. Due to effect of moisture, a layer of reddish-brown color is deposited over surface of iron called rust. Its chemical formula is Fe2O3NH2O. The slow process of decay or destruction of metal due to the effect of air, moisture, acids on it is known as corrosion. Prevention of corrosion is always necessary. It will not only save money but also prevent accidents. Corrosion damages buildings, bridges, automobiles, ships and other articles mainly made of iron. It can be prevented by using anti-rust solution, coating surface by paint, process like galvanizing and electroplating with other metals. We all have heard about oils becoming rancid. Let us learn in detail about rancidity. Visit an oil merchant. Request him to give you 100 milliliters of leftover edible oil from the tin. Heat it in a container. Note your observation. The oil gives foul smell. When leftover edible oil is heated, it starts frothing up and its smell turns foul. If food is cooked in this oil, its taste changes. This is due to oxidation of oil. When oil and fats are oxidized or even allowed to stand for a long time, they become rancid. Antioxidants are used to prevent oxidation of food containing fats and oils. Storage of food in airtight containers also retards oxidation. Students, let us find out the names of some natural antioxidants. Nowadays, many antioxidants are available in pharmacies. List some brand names. Brand names of antioxidants available in pharmacies are BHA, that is, butylated hydroxyanisole, and BHT, that is, butylated hydroxytoluene. Kurkure, chips, fryums, etc. are stored in airtight containers. Is it enough to prevent oxidation? It prevents oxidation for short time. What more steps are taken to prevent oxidation of edible articles? The plastic is filled with nitrogen gas to prevent chips from being oxidized. Nitrogen is unreactive gas and packets flushed with nitrogen does not have oxygen to cause oxidation. Let us study about neutralization. After you have your dinner tonight, wash your own plate with soap or detergent. What color change is observed when soap or detergent is applied? Yellow to red-orange. Can you name the type of reaction? It is a neutralization reaction. The yellow oily leftover stains will turn red-orange because of neutralization. Edible oils are organic compounds and you will be learning about them in the chapter on chemistry of carbon compounds. Edible oils are compounds of alcohols and organic acids or carboxylic acids. The compounds formed are known as esters of carboxylic acid. These compounds in edible oil are neutralized by alkaline soap or detergents. This neutralization reaction is indicated by turmeric, which is yellow, which turns red. Acid plus alkali or base gives salt plus water. This is neutralization. We will learn more about neutralization in the chapter of acids and bases. Well, that ends the chapter. Hope it was a joyful learning. You have the options to view a mind map for a quick recap and a question and answer section to study the exercises. Wish you all the best. Bye till we meet again.